In our last video for advanced higher, we were looking at the equations of angular motion. So now today what we're going to look at is equations for tangential motion, okay? So tangential is when something's moving in a circle and then it goes off at a right angle to the radius at that point, okay? Now, you'll recall from the last video that the angular displacement of an object theta is equal to its displacement around the circle divided by its radius. And so this relationship connects the angular and the linear concepts of angular motion, angular displacement and linear displacement theta and s. Okay, and if we differentiate both sides of that with respect to t, you'll get d theta by dt is equal to ds by dt times 1 over r. And we know that d theta by dt is the angular velocity, and ds by dt is velocity, and that'll be over r. And so that gives us a new equation here of the angular velocity is equal to v over r. Now this v here is going to be our tangential velocity. Okay, so the velocity that this object would have if it came off at a tangent to the circle it's going around at any point, as long as it's a tangent to the circle, the velocity would be this relationship here. Okay, and if we rearrange that so it's all on one line, we would get v is equal to omega r. Okay, and similarly, if we needed to look at tangential acceleration, okay, if we differentiate both sides of that equation there with respect to t as well, you would get dv by dt is equal to d omega by dt r, and dv by dt is a, d omega by dt is alpha, and r. Okay, so again, differentiating with respect to t, and we get the relationship between angular acceleration and linear acceleration. Okay, and so if we have a circle here and we work out the radius of that circle there as r, okay, and we have an object at 90 degrees which has an acceleration a, and as it's going round the circle it has an angular acceleration of alpha. Okay, if we increase the radius, then the tangential acceleration will increase even if the angular acceleration remains constant. Okay, and so we're going to do a couple of worked examples. So we've got a mass on the end of a 1.2 meter rope being swung with an angular velocity of 4 rads per second. What is the tangential velocity of the mass? So we're looking for v, we have omega is 4, and the radius is 1.2. So v equals omega r, 4 times 1.2, which is going to be 4.8 meters per second. Okay, and another worked example here. Calculate the tangential acceleration of an object which has an angular acceleration of 4 rads per second, and moving in a circular path with a radius of 2.4 meters. So it says we've got an angular velocity of 4 and a radius 2.4. Okay, and then a is equal to r alpha, so 2.4 times 4, which is going to give us 9.6 meters per second squared. Okay, and that's how we relate tangential and angular velocity together. Don't forget, guys, to give the video a like and to subscribe to the channel for more videos for advanced higher physics.